Hey everyone, in this video, let's take a look at question 424, longest repeating character replacement on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, you're given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. We want to return the length of the longest substring containing the same letter you can get after performing the above operations. Okay, so let's see what this question is saying here. Copy the examples, paste them here. Okay, so we have k equal to, which means we can essentially replace two characters, and when we replace those two characters, we want to form the longest string that we can, or possible longest substring. In this case, we can actually just replace both of these a's with a b, which will give us b, 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 a length of 4, or either we can replace these two b's with just a's. And so you can see that for every replacement, our k will go down 1 and then 0. Right, so we can do that. And so in this case, actually, we can replace any of them to get the length of 4. In this case here, we have just k equals 1, right? So what can we replace? Well, there's many locations, right? Maybe we could turn this one into an a, so this would give us like a length of 4, which is actually the right answer here. We can maybe turn this into a b, which also gives us a length of 4. If we turn this into an a, well then it's not really the best, right? Because this is just maximum length of 2, so it doesn't really help here. Okay, so how might we go about doing this problem? And in this problem, I think it's a little bit tricky in that the way the question is phrased, right? It kind of makes you think that like you have to know the character that you're replacing, right? Like I have to know here that I'm going to be replacing the A with the B, and maybe like it's more difficult in that sense. But really, kind of the trick in this problem, and I wouldn't really put this as medium. I would kind of put this as harder, simply because of like the trick is a little bit harder to understand. But once you understand the trick, right, then the question actually becomes really simple. And to kind of motivate the trick, let's consider a simple example here. Well, first of all, right, let's say we have s and k and s, right? So maybe we have something like apple, and then k is equal to something like 7. If this is the case, then what can we do? Well, we know right off the bat, right? If k is greater than the length of s, then the maximum number of replacements you can do is the entire string itself, right? And actually, I don't think we're okay. So I don't think we'll run into that example, but just kind of to illustrate a point here. So if our k is greater than our length of the string, then the maximum number of replacements we can do is just exactly that, right? Just the length of the string itself. So maybe let's consider something smaller. Maybe we'll consider k equals 2. And so you can kind of see here that like p and then p here will give us a length of 4, which turns out to be the best solution. But how can we maybe like think about how can we do this, right? So if we think about this, we have to consider substrings, right? So whenever you have to consider substrings, you might want to think about like a sliding window type approach, right? And the reason that makes sense is because often in these types of questions, like longest something in terms of like a string, where when it's not like dynamic programming, then often the answer is like through just through like sliding window. So if we take a look at like similar questions, so you can see here like longest string with most distinct or maximum number of ones. All of this is like just sliding window type problems. So why might sliding window be useful here? If you think about this, let's say in sliding window, what do we have? We have 2 pointers, right? We have a left pointer and we have a right pointer, and we consider a window. In this case, we're just considering the window of A. Now, we already agreed on that if the length of the string is less than k, less than or equal to k, then the maximum number of replacements we can do is just 2 itself, right? So we don't really care about this one. But maybe something we could do is like we could record that we've seen an A. So how can we do that? Maybe we have something like a map or a counter in which we say, okay, we saw 1A. Okay, then what happens? Well, then we increase our counter to 2, or we make it like we advance the R. So now here, I have P is equal to 1. Okay, so what does this mean now? Well, in this case, it's still like less than or equal to K, right? So still I can do at most K replacements, at most like 2 replacements, in which case I would just replace the entire string here. So maybe let's consider one more case in which we move the A or we move the R pointer ahead 1. Now, P is equal to 2. Okay, so now here's the real question, right? Like, here's the real question. I have something like this, and my K is equal to 2, and I can replace 2 characters. Now, what do I want to replace? Now, it turns out that we don't actually like care about the actual combination, right? Like, we don't care if we do something like APA, we do something like maybe AAP, or maybe we do something like just PPP. We don't really care about like all of these combinations. All we really care about is like the maximum count I can form. So that's where like the understanding of this question comes from. What is the maximum count I can actually form? And if you kind of think about this, what's a letter we don't want to replace, right? What's a letter we don't want to replace? And maybe to kind of motivate this, what if I put it like this, right? What if I put it like this? Well, if you really stare at this, the letter that we don't want to replace is the P, right? Because why? Well, the P appears like most often in the string, right? It appears 2 times in the string. So it would make more sense for us to actually go ahead and replace the remaining letters such that if we somehow replace them, then maybe they can form like a substring that has the P inside of it, in which case it would be like potentially one of the longest substrings, right? So in this case, it actually makes sense to replace the A here with the P. And really, if you think about like what we're doing here, like we're taking like the maximum letter, like the frequency, and then we're trying to basically subtract that by K to see, or like we're trying to basically subtract that by K to see like, not K, I mean like the size of the window. So in this case, like we have the size of the window as 3, right? And so here I can see that I have P occurring 2 times. So really what I would like is I would like to replace the remaining characters, which is just A in this case. I want to try to replace that as much as I can such that we abide by the K property. So here we have like some sort of condition, right? So what a condition could be here is could be like size of window minus max occurring character. This must be greater than or equal to K. Or I'm sorry, not greater than. It should be less than or equal to K. What this means is that we could do, at most, K replacements. I'm sorry, I don't know if you can hear the siren in the background, but hopefully it's not that loud. But let's move forward, right? So we have like some sort of understanding here. So the size of the window, which is 3 in this case, we want to replace the letter such that it becomes the maximum letter. So in this case, we'll replace the A such that it becomes like a P. And we continue to do this as long as we have replacements left. So if we continue to follow this, this would be like valid, right? So this is like length 3. This is one of our results. So we would just put like, maybe result is equal to 3. And now K here is actually 1, right? Because we've done a replacement over here. Now maybe I can advance the R even more. Well, if I advance the R even more, again, what do I have? Well, now I have L is equal to 1. And now it really becomes obvious, right? Like that we should replace the A and the L because they are occurring less frequently than the most frequent letter. And so what we want to do is we want to replace the least occurring or like the less occurring letters such that they might become the like most occurring letter. So how can we do that? Well, in this case, if you think about it, now like even though like K is 1, we're still like on this condition here. So we won't actually like be decreasing K here. So we'll just kind of like take a look and like see how many characters we can replace. But here we can see that we can replace 2 characters, right? Because we can replace this one, we can replace this one. And so here like K would become 0. But again, we won't be changing K, but like as per our condition here, we'll just be checking that. Okay, so now I know that this is my maximum, right? This is my maximum. Now, what happens if I move R over here? Well, if I move R over here, here we'll have E is equal to 1. And notice that the length of my window is 5, and the maximum occurring letter is 2, which means that if I want to make these 3 into my 2, into my P, then I need to do 3 replacements. But this is not allowed, right? Because our K is capped at 2. And so if you think about it, this is like a case in which our window breaks. And so what we do when our window breaks is we move our left pointer inwards because we can't consider this entire string here, but maybe we can consider this one. So if I move it inwards now, then this the A disappears here. And now we can see that we can actually replace this. And so then this condition holds. And so we'll replace both of these with the P. And so we'll get a length of 4. So that's essentially the algorithm. It is a sliding window type algorithm. And let's take a look at the code to see if we can further make sense of this. But what do I need? So in sliding window, one of the first things I need is I need to check that when I don't need to check anything, I can have my left and right pointer. So left is 0, right is 0. And while left or while right is less than the length of S, then we do our stuff. Well, what else do I need? Well, I need like some way to keep count of the letters that I'm seeing, right? So I'll have just a dictionary, which I'll call D, and then this will just be an int. And now what do I need to do? Well, the first time I see like that I'm on a letter, I will increase its count, right? Like when we're over here, we increase the count of A. So I will do S, or do D at S at R plus equals 1. So this will basically increase the count at the letter on the right pointer by 1. And then what? When then we have our condition here to check, right? We can check that if the size of our window, which is R minus L plus 1, if this minus the maximum occurring character. So how can we get this? Well, it's kind of like a trick in Python, but essentially what you do is like if you do d dot values and you find the maximum, what this will do is this will like look in your dictionary. So our dictionary will be like maybe it'll have like, for example, A will be 1, P will be 2, right? And so it will look in the values. And so d dot values is just 1 and 2, and then it'll get the maximum, which is just 2. And so that's how we arrive at our answer. So if this value is greater than k, right? If it's greater than k, then what? Well, then we know that like we're at a condition in which like we can't we can't expand our window anymore. So what do? Well, we increase the left-hand side. So first of all, I need to decrease this pointer on the left-hand side, right? Like I need to decrease the count because I'm getting rid of a letter. And then I will increase my left pointer. And now you may be asking, like, how do I figure out my result? If you think about this, like, what is my result, right? Like initially, we're over here, and we already argued that if the size of the window is less than k, then that has to be our result, right? And if you really think about what we're doing, so here my result is 1, now it's going to be 2, now it's going to be 3, now it's going to be 4, right? If you really think about what we're doing, we're just setting result equal to the size of the window, right? Because in any case, like maybe if I arrive over here, but like obviously like this is not valid, so we'll move this inward by 1. We're still always maintaining a valid window that like will satisfy this equation here. So if you think about it, my result will always be the maximum result and the window size, which means we have to define result at the start as 0, and then that's basically the solution here. Let's take a look. We'll run it, and I have to increase R by 1. That is why it is taking a while, but let's go ahead and do that, and we'll run it. And we can see it passes. So the time is actually just O of n. This is pretty much like a simple like it's kind of like constant time, because maximum you have like 26 letters, so it's still like O of n. But again, like why does this make sense? Like why is our result going to be the size of the window? Because like every time like we make our call, initially the result is just 1, right? Because when the size of the window is less than k, then the answer is just the size of the window. So here it's 1, here it's 2. Here we're still valid, right? Because this is still like a valid configuration. We're only going to replace 1 letter here. So now it's 3, now it's 4, right? Now it's 4. Now we'll try to add in another one, but we'll see that this breaks the window. So then we'll move our L in 1, and we can see that this is still like a valid window. So that's why like our result here will always be like this valid scenario here. So this is basically what we're doing. It's one of the strange sliding window type problems in which your answer is actually just the size of the window itself. But yeah, that's what this problem is. Anyways, thanks for watching.